All right, good morning. So we're going to continue talking about Trapezoid Rule and Simpson's Rule, etc. All right, here we go. Sharing the screen, and let's see what we've got. All right, so something like that, like this thing, and then what we have some homework. So we were talking about this one yesterday. We're getting to this one. So find the area of the semicircle above the x-axis. This is very similar to your worksheet this week. So it says n equals 8. Use the following methods: trapezoid, Simpsons, and compare the result with the actual semicircle. All right. So let's draw a little bit of what's going on here so we can get started with it. All right. So the idea here, right, is we have a function equals, well, not the function. We have the relationship x squared plus y squared equals 64. Okay. We're starting like a step 0 here rather than where we are, just so you can see that it's a circle. So we have y squared equal to 64 minus x squared. When your worksheet says to solve for y, this is what you're doing. Okay, so y is equal to plus or minus square root 64 minus x squared. Okay, and notice I said above. So if you look here, it says we'd like to above the x-axis, n equals 8. So we're going to pick this spot right here. Okay, we want the positive side of this. So what we're looking for is, let's go with 4, 8, 4, 8. These are negative, 4, 8. Okay, so we're trying to, I'm just going to say pretend this is round. Okay, and the idea is that we're going to put every 2, right? Because they want n is equal to 8. So we're going to divide this up into 8 little spots here. So if we take 8 minus negative 8, right? B minus A, divided by 8 divided by n, right? We get 16 over 8, which is equal to 2, or delta x, or h, is equal to 2, right? So we're going to negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, and then 8. All right. So what we're doing is we're just coming up with, like here's the trapezoids that we're going to be using. Same idea with the with Simpson's rule, except instead of trapezoids, we're going to be using parabolas. So it'll be a little bit closer here. Okay, let's go ahead and find out what the actual value is first, and then we can go back and like try the numeric methods. Okay, so we have pi r squared should be our area, but that's for a circle, but we only want the top half of it, so 1/2. Okay, if we wanted the whole circle, right? Actually, we don't have to, yeah, 1/2 pi r squared. So we're going to do pi, and our area, or my radius rather, is 8. So we have 8 squared here. Okay, so we have 1/2 times 64 times pi, right? 8 squared, 64. Half of 64 is 32. Pi, that's going to be our eventual area that we're aiming for. Okay. If I wanted the whole circle, right, we just would multiply by 1/2. So if you want like a whole ellipse, for example, we would just multiply by the formula given for it, which is AB pi. Okay, it's for ellipse. And just in case something like that would ever come up. All right. I wouldn't expect you to memorize the formula, by the way. It's something you would be given, but area of circle, I would expect you to know. Okay. So numerically, what is 32 pi? So we can go back and do this. So we want what 32 times second function pi. And what is that? 100.531 to 3 decimal places. All right. So next little spot here. What we're going to do, all right, is we are going to go ahead and set up our trapezoid. Well, actually, what we're going to do is we need the values at -8, -6, -4, -2, and 0. We need the values at each of the x's are each going to visit here. That's by -2 or -8 rather, counting up by 2's until we get to +8. So if I wanted to do something like show my functions, we'd have y equals square root of 64 minus 8 squared. If I'm going to go set up my little graph here, I think what are we doing here? We are looking for not table set. Let's just try this window. Okay, so in this case, I went from -9 to +9. Okay, just a little bit more than -8 to +8, and I scaled it from 0 to +9, and then we'll just have graph it. Okay, so if I want a semicircle, that's big surprise there, right? Let's do our table setup because I really wanted to do the table. So we're going to start from -8. Okay, we're going to change it to 2. And then when I go to table, we're just going to go ahead and see what's happening here. So we're going to say table. Oops, I want second function table. And effectively, I can just write these numbers down, okay, rather than calculate each one of them for each piece here. If I wanted to go ahead and calculate them for each piece, it's not that big of a deal, so it's not that huge savings of time, but we would have our x and our y. We have -8, -6, that's an 8 by the way, sorry, -4, let's keep going down here, -2, 0, and then we have to do 2, 4, 6, and 8, okay? So we just have 2, 4, 6, 8, okay. Times like this, you'd like some line paper, okay, rather than just doing it freehand, but there we are. All right, so let me move this over. So we're just going to have 0, and this is going to be 5.2915. It says keep our intermediate calculations to 4 decimal places so we can round to 3. So that's what we're going to do here. That was how the calculator turned it out. I guess we could go and figure out how to make it do more if we wanted to, but I know I'm going to have to look around for that. So that's 6.9282, 9282, 7.746, 7.746. This is going to be 8. And then because it's a symmetric thing, right? The circle, we're going to have 7.746 here, 6.9282, 5.292915, and then finally 0. Okay. All right. So to do the trapezoid rule, right, we have b minus a over n, right? And then what we're going to have is 1/2 of the first one plus 1 of the second one plus 1 of the third one, okay, etc. All right, so that's just what we're going to do, is just we're going to half of the first one, which is 0, okay, and then we're just going to add these up, okay. So b minus a over n happened to be 2, I believe, b minus a over n, so we have twice. Okay, and then we have 1/2 times 0. I don't think you really need to write that, but then 5.2915 plus 6.9282 plus 7.746 plus 8 plus 7.746 plus 6.9282 plus, oops, we already did the plus there. Okay, 5.2915 plus 1/2 of 0. Because it's symmetric, I just wrote down the twice of all of these. Okay, and then we're just going to add these up. Okay, yeah, 1/2 times 0 for the beginning. All right, so that's what we're going to have. Okay, best of luck for adding this up here. All right, so yeah, we don't have to type in the 0, right? So we just have 5.2915 915 plus, you can see that if you maybe manage the spreadsheet, this may have been a little bit better, which is fine. 7.746 plus 8 plus, and I really could have made this a little bit better because notice there's two of these, two of these, two of these, and then one of those, and I could have added them up that way instead. Okay, but just being naive about it, and we're just going to go ahead and do this thing, which of course increases 7.746 plus 6 increases the likelihood of making an entry error here. It would have been smarter to make that a smaller thing. 9.2915, and then plus the 0, and we're set. Okay, we'll just say enter. Fingers crossed. Okay. What did I do? Oh, wait, no. 70. Oh, there it is. Instead of 7, I'm going to go a little bit faster then. I'm going to say, look, we could add these up, so that's twice 5.2915 plus 2 times 6.9282 plus 2 times 7.746 plus 8. Okay, I'm just adding up and combining the terms that are easy to get. Okay, and we could even do one better. We could say 8 plus, and then there's a 2 in each of these terms. So twice times, and then parentheses, and then just put all the long numbers in the parentheses. So that's 5.2915 plus 6.9282, okay, plus 7.746, and parentheses. I think you have to do that either, but that gets all of this stuff here. We have 1, 2, 3 numbers here times 2, and an 8 at the end. All right, so there we go. So it's 47.9314, and I do believe I never multiplied by that first 2. Okay, so we're just going to put that in there. So times 2 equals, and we ended up with 95.863. And that is the trapezoid rule. Okay, so there we go. Okay, and that is approximating 100.531. Okay, so again, real answer is 100.531. This is actual. This would be experimental. All right, so let's see if we get a good answer here. We have 95.863. 95.863. 95.863. Fingers crossed, checking. Okay. I don't know what the tolerance is. Okay. Simpson's rule, approximate the area of the semicircle. So like I said last time, like if I was off, I'd double check to see if I could find the answer real quick. But I would not spend 3 hours doing this homework. Okay. At a certain point, it's like, look, you can have those points. I'm not going to take them. All right, let's see. So Simpson's rule, I'm just looking for Simpson's rule to write down here. And again, you're not responsible for memorizing Simpson's rule, okay? So it's going to be provided to you. B over a minus n, or over n rather, let me say over n times a third. We have 1, 4, 2, 4, 2, 4, 2, 4, 2, 1. Okay. So going back down, sorry for the long trip here. So we have 1/3 times b minus a over n, okay? And now we have fx0 plus 4, fx1 plus 2, fx2 plus 4, fx3 plus dot 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 until we get to finally 4fxn minus 1 times 1 of the last ones. Okay, so what I would do here is kind of make my same sort of table that we did in the first time I did this. So okay, again, line paper would be nice. All right, and then we have our x's, we have our y's. I'm going to put my coefficients in. That's the 4, 2, 4, 2 business. Okay, and then it's terrible anything. Yeah, let's call it coefficient. You can read that, or I'll just call it weights for W. Okay, so we're just going to do W times fx or y, and then when we're done, we're just going to add these up. Okay, that's the plan. Oh, and then we divide by 3. So we'll get a sum, and then 1/3 of whatever we get up here. That'll be our answer. All right, calculator time. So there's my table. Okay, this is going to go a little bit easier for you because I know you're going to be able to have everything on one page. 0, 1. Okay, we have -6, 5.2915. Weight is 4, correct? And then -2, and we have 7.746, 2, 0, 8, 4, the weight, 1, 4, 2, 4, etc. Right? And then we have 2, 7.742, 746, rather, 746. We have a 2 here, okay, and then we have a 4. Oh, I forgot 4. All right, hold on. Let's do this. Rather than do the whole thing over again, this is going to be 4. Okay. Completely over it. Okay, let's get rid of that. What? Yeah, that's an eraser, right? No, this is the eraser. All right, let's get rid of all of this. Again, this is why we invented spreadsheets. Okay, so here we go. These are negatives. Okay, -2. Come on. I caught that before I went too far with it. Okay, 464 or 864, -2, 0, 2, 4, 6, etc. All right, so at -4 we are at 6.9282. 6.9282. Okay, this is still correct. At -2 we are at 7.746. 7.746. It's a 4. Okay, 0 is 8. That's a 2. Okay, now we are back to 7.746. That's up to a 4 again. Okay, 6.9282. That's back down to a 2. Okay, at 6, this was 5.2915. This got up to a 4. And then finally we get up to 8. Okay, this was 0, or yeah, this was 0. And then we just have our 1 there. Okay, go ahead and erase this. We have some room. Okay, by the way, this is not like the way to do it. If you happen to have a better way or a different way than mine, that's fine. Okay, I just organized it in the way that kind of came to me. But you know, there's plenty of other sort of organization methods to do this. So y times the weight is 0. Then we have, let's get out of here quick. Okay, and then we have 5.2915 times 4. Okay, and this is going to be 21.166. 21.166. Okay, this was 0. 21.166. Okay, and then we have 6.9282. 13.82, okay, times 2, okay, is 13.856, okay, so let's go down here. So this was 13.8564, okay, that's the 4 here, and -2. Okay, so what do we have for -2 here? We have 4 times 7.746. 7.746. Yeah. Okay, and that's 30.98. Right, 984. Okay, this is 30.984. This one I think I could do. And then we just got to add these up. Okay, delightful. So I'm not going to try to do anything fancy here. I'm just going to see if I can add them up correctly this time and have a go at it. All right, so this is going to be 21 point, what was that? 21.166. 166 plus, let's see, 13.854 plus 30.984, okay, plus 16 plus 30.984 plus 13.8564 plus, okay, what was this? This was 21.166, and then we're just going to go with that. Hope for the best. Okay, 148.0104. That seems terribly wrong. Okay. Yeah, this seems terribly wrong to me. All right, because the next thing we have to do, right? Oh, we have to multiply this whole thing by 2 because that's what this is, and divide it by 3. So this is times 2/3. That seems a little bit better to me now. Okay, so times the b minus a over n, that was the 2, divided by the 1/3. So we have the thing in front, enter. We ended up with 98.6736. That looks about right. Okay, so this is 98.6736 for our answer, 98.674. Okay, and remember our answer was supposed to be like 105. Okay, so it's not too off, but that's my value for this thing. Okay, 98.674. 98.674. Fingers crossed that actually works. All right, nope, it didn't like that at all. Make sure 42. Okay, 424242. We got that going on right. I'm not going to worry too much about the fact that I messed this up somehow. 98.674. I wish I could just tell me, like, solve this instead of telling me to do this. We'll just say check and check. We'll make sure we got. Wow. 98.675. So the tolerance is pretty tight. I'm sorry about that. This is why I wouldn't fight with it too much. Like, give it the best shot I have and like not worry about points for this, because you know, if you gave me this answer, I wouldn't really care. That's fine. The whole reason of giving me, if I say give me 3 answers, 3 decimal places, the reason why I do that is because I want the second, I'm going to grade to the second one. Maybe I just didn't round right. No? All right, I'm not sure. I should have gotten a 4, but they said they wanted a 5. All right. Actually, I think I know where it is, and that's because they said the round of 4 decimal places when we did this. Okay. Wow, this is so picky. No, we did that right. That's all we got was 4 decimal. I don't know. But there we are. Okay, like I said, I wouldn't worry too much about that. Okay, I know everybody wants perfect scores, but there's also fighting with technology and how much do you want to do? 100.531. 100.531. All right, check. I'll make your answers in terms of pies. Okay, exact answer in terms of pi. All right, that was 32. What was that? It was 32 pi. Read the instructions first. Okay. Round to 3 decimal. Now we round to 3 decimal places. What are you doing? Okay, 100.531. All right, very nice. Okay, it looks like the Simpson's rule got a little bit closer. Okay. Oh, no, it didn't. Yes, it did. 98 versus 95. So Simpson's rule. This is always going to be the case. The Simpson's rule is always going to be just a little bit closer than everything else. Okay. So that's pretty much how you do this thing. All right. Like I said, I would not be too maniacal about getting exactly the right thing, getting 100 on this. You have other things to do in your life. Okay. So we've got that. All right. So, all right. So this one, they want to know, okay, there's the difference between the true value of the integral and the value given by that is known as the error. It's kind of a cool class to take for like numerical methods. But this is the kind of thing you worry about is like out to like the 16th decimal place, like which one is better. Okay. And how long it takes to calculate things. That's another thing that we care about. Okay, terminal large n has to be for the error to be smaller to some specific point. So we did this a couple of times at the beginning. It's like n is this value. Okay. Actually, I'm going to stop us here. I'm going to say good luck with that problem. I will do a part 3 and then we'll be okay. All right, so thank you, and I will see you in the next video.